we will see left hand derivative and right hand derivative. Okay. So what is left hand derivative and right hand derivative? So derivative actually is denoted by dash. First we will see, okay, left hand derivative and right hand derivative. So f dash x we denote by f dash x. Derivative of x is denoted by f dash x, or it can also be written as d by dx, means derivative of fx. And its general definition, like you have seen that left hand limit is equal to right hand limit, then we can say limit exists, then we can write directly limit. If left hand limit is equal to right hand limit, we can say that the limit exists, and we can write the limit without writing left hand or right hand extending to a fx is equal to L. If left hand is equal to right hand limit, then we can write directly limit. Similarly, here also we have to find the left hand derivative and right hand derivative at a point. At point, suppose this is our point C. At this point, we have to find the differentiability of this function. I will tell you what is the meaning of geometrical meaning of differentiability. First, we will see left hand derivative and right hand derivative and differentiability. Okay, so a function is said to be differentiable at every point if left hand derivative is equal to right hand derivative, then they are differentiable. So how we will write this differentiability or derivatability? We can say differentiability, or this is called differentiability. Differentiability or differential or derivative, same thing. Huh? So, or we can say derivability also. We can say derivability. Now your calculus, differential calculus starts now. Okay. So differentiability. What is the differentiability? So before that, left hand, as I told you, left and right hand derivative are equal, then a function is said to be differentiable. So a real function, how we will define a real function? F is said to be differentiable. We will not use derivable, we will use differentiable generally. So it is differentiable. This function is differentiable at a point C. At a point C in its domain. Domain and range we have already seen for functions. So in its domain, if it is differentiable in its domain, a function is differentiable if its left hand and right hand derivative, if its left hand derivative, I will tell you what is left hand derivative, how to find it. So if its left hand derivative and right hand derivative at C, and right hand derivative, right hand derivative at C, at which point at C exists and are equal. First of all, they should must exist, otherwise they cannot be equal. Then if they are equal, then we can say that function is differentiable at that point. So we used to write left hand derivative as f dash c, means left hand derivative at c is equal to right hand derivative at c. In general, we write left hand derivative. Formula for left hand derivative is, when we are finding the left hand derivative, as you have seen in left hand limit x tending to c negative, small negative. So we will give the increment to c minus h. But here we are not writing fx because derivative is actually, it is the slope of a tangent geometrically, and its value is, if you are finding at c, so its value will be limit, general value is limit x tending to h fx plus h, small increment we used to give, minus fx divided by h. This is minus. I will write clearly here. So derivative of a function is denoted by f dash, and its general formula for any derivative fx, directly if we are finding derivative directly. We are taking here differentiability. If the function is differentiable, we can find the derivative. So in order to find the derivative, we will write limit h tending to 0. This is the value of derivative of any function we can find by using x plus h in small increment minus fx upon h. This will give you the value of the derivative. First of all, now come back to the left hand derivative. So in order to find the left hand derivative, we can write fx minus at 3 points, so fc, and divided by x minus c, and c is replaced, then c is replaced, so you can use directly this formula also, limit h tending to 0, and x is replaced by c minus h, c minus h minus fc, and this x is replaced by c minus h. So c cancel, only minus h will be left, so negative h will come. For left hand derivative, this formula will be used. Similarly, for right hand derivative, same thing. For right hand derivative, we will use limit x tending to c plus fx minus fc divided by fx minus fc divided by x minus c. Okay. X minus fc divided by x minus c, and when you replace x by c plus h, this is plus, because right hand side we are taking the derivative at right hand side of this, c plus h is here and c minus h is left side. H is very small possible value. Okay, so limit, it will become limit h tending to 0 f c plus h, c plus h minus fc. The increment, we are giving the increment in this c plus h, c minus h, and divided by, when you write here c plus h, c cancel, only h. So here minus will come. What you have to remember here, minus will come, here plus will come. Here negative value minus h, we take minus h, this is minus h. This is what? Negative value of h minus h, and here we take plus h. Here minus h, and here we will take plus h. Okay, so by this way we can find the derivative. Differentiability, working rule will be left hand derivative, right hand derivative, and then find the differentiability. Okay, so we have one question. Discuss the differentiability. The question is, discuss the differentiability. Discuss the differentiability of function fx is equal to, very simple question, fx is equal to x square at x is equal to 1. This is differentiability. Differentiation we will directly find. We will have many formulas to find the differentiation. This is differentiability, to find whether the function is differentiable or not. Geometrically, the meaning is if we draw the tangent at that point, then it is differentiable at that point. We will discuss that later on. So first we have to check whether it is differentiable or not. So at x is equal to 1 we have to check. Okay. So we will find left hand derivative first. Find the left hand derivative. Left hand derivative. As you know, left hand derivative limit we have seen just now. Left hand derivative is h tending to 0, c minus h minus t minus h, left hand derivative. Huh? So we can write directly, okay, h tending to 0 and function is written c minus h minus fc. But what is c? Here c is equal to 1. So instead of c we can write 1. Okay. So 1 decrement of one number, decrement of h from 1 minus fc, that means f1 divided by, because it is a left hand derivative, minus h. Okay. Now use this value. If we want to find value of f1, f1 is equal to what? 1 is square, that is equal to 1. And then if you have to find value of 1 minus h, 1 minus h will be equal to 1 minus h whole square. So these values substitute here to get the left hand derivative. So we get limit h tending to 0, 1 plus h, sorry, 1 minus h whole square minus 1 divided by minus h. Limit h tending to 0, 1 square minus 2h plus h square minus 1 upon minus h. And as you know, this type of limits only it can be calculated when this denominator h is cancelled or it is absorbed in some formula. Otherwise, this will become infinity. So here also you will find this will be cancelled. Then you can put the value of h 0. H tending to 0. Now minus 2h plus h. So h you can take common. So minus 2 plus h, and this h minus h will cancel. We get minus 1. This minus you can multiply above. So it will become h minus h plus minus h plus 2 because of this minus, and limit h tending to 0. Then answer is 2. So left hand derivative, we got the left hand derivative as 2. Similarly, for right hand derivative, limit h tending to 0, at which point 1. So we will give the increment of h in 1, f1 plus h minus fc upon, you can write the formula just starting, then you can substitute, otherwise you can do it directly. Now we can have the formula and we can put the values directly here. So limit h tending to 0, h tending to 0, h tending to 0, f1 plus h means 1 plus h whole square as per the definition of function here, and value of 1 is 1 divided by h. So limit h tending to 0, 1 square plus 2h plus h square minus 1 divided by h. This minus plus cancel, h is taken common, and then you put the value of h, you will get 2 again. So left hand derivative is equal to right hand. Therefore, we can say that left hand derivative is equal to right hand derivative is equal to 2. Therefore, hence fx is continuous. Oh, sorry, differentiable, Hence fx is differentiable at x is equal to fx is differentiable at x is equal to 2. So like this we can check the differentiability, and for left hand derivative, as you have seen in continuity, left hand derivative, if the function is defined by only one definition, if it is different on both the sides, suppose this c less than 0 is different, greater than c is different, then we have to use the left hand definition for finding left hand derivative, and definition greater than for c0 use for right hand derivative in calculating right hand derivative. So that question you can take from your textbook also. I think there are very few questions where we have to check the differentiability. Let's see. Differentiability is explained here, and we will see one more thing, the geometry and composite functions. You can find here prove that the function is not differentiable at this. Only one question is there, it's not differentiable. Only these two questions are based on the differentiability. Then differentiation starts. So we are not only focusing more for differentiability, because in textbook we have given very less number of questions. So we can take these two questions to check the differentiability. Exercise 5.2, correct? Well, this is very vast chapter. We will continue extra classes after, means when the holidays start. I will tell you when we have extra class. So in a week, once in a week, I will take, not more than that, inshallah. So you can see here differentiability is asked in question number 9. So we have to check the left hand derivative and right hand derivative. So I will take this question first. Okay, so 5.2, question number 9. Prove that the function is differentiable, is not differentiable, sorry, is not differentiable at modulus of absolute value of x minus 1. So as you know that here we have, we should not start directly for modulus. For checking differentiability and continuity, we should start from the definition of x minus 1 mod. As I told you, this is x minus 1 if x minus 1 is greater than equal to 0, or you can say x is greater than equal to 1, same thing, minus 1 will come here. Similarly, it will be negative, means x negative x minus 1 if x minus 1 is less than 0, or you can say x is less than 1. So what point we have to check? At one point this function is having different definition, different values, left hand and for right hand. So we have to check at one differentiability. That means we have to check differentiability at one. Okay, differentiability at x is equal to 1. So left hand derivative, right hand derivative we will use. So left hand derivative we can write like this also, f dash left hand derivative at 1. We have to find at 1. So limit, as you know, h tending to 0 and 1 is increment. 1 we have to check. At 1 we have to check. So c minus h means 1 minus h minus f1 fc upon minus h. So left hand derivative. So fx is equal to which definition we will use? This fx is equal f modulus of f of x minus 1 is equal to x minus 1. What? Okay, this definition we will use. So f1 will be f x. Sorry, what I sorry. Fx is equal to x minus 1 for left hand derivative, and we are for right hand derivative here we are using left hand derivative. For less than 1 left hand derivative, so the formula will be minus x minus 1 minus x minus 1 means minus x plus 1 also we can say. So by this definition, this limit h tending to 0, x is replaced by minus x. X means 1 minus h. Here x is 1 minus h plus 1, and if you put f is equal to 1, so value of 1 is 0, because minus 1 plus 1 you get 0. So that is minus 0. No need to write in minus h as it is. Then you multiply minus 1 plus h. This will become plus h. So limit h tending to 0, numerator will become h and denominator is minus h. H cancel. So minus 1 is the value of left hand derivative. So then right hand derivative at this point will be equal to limit again h tending to 0, and this is written c plus h, 1 plus h, 1 plus h minus fc, that is 1 divided by h. And now formula will be used x minus 1, fx is equal to x minus 1. So this value will be h tending to 0. So 1 plus h minus 1, and f1 is 1 minus 1 divided by h. So this minus plus cancel, and 1 minus 1 0, only h is left. H upon h is equal to 1. So minus 1 is not equal to plus 1. Hence it is proved that you can say therefore, since left hand derivative at 1 dash means derivative is not equal to right hand derivative at 1, therefore fx is not fx is not differentiable at is not differentiable at x is equal to 1. So like this we can check the differentiability of other question. Next question we can check 10th question also, but prove that the greatest integer. I told you how to check the continuity. Here there are two parts. At x is equal to 1 we have to check the differentiability, and x is equal to 2 also. So use the same definition that we have done. If you want, I can do it. Okay, this also I'll take. Greatest integer definition. Just remember the definition of the greatest integer, and I explain you why that definition arises. You remember what was the definition? Do you remember? Then go back. Yeah, this is the greatest integer. This is the definition: a minus h, a minus 1, and a plus h, a. This you remember on always. Fa minus h for greatest integer less than equal to x, a minus 1 for negative a minus 1, and positive it will be a only. So what we have seen, a minus h will be equal to a minus 1. F x is equal to this a minus h, a minus 1. Okay, like this. F a minus h, a minus 1, f a plus h, a. So f a minus h, when you are finding f a minus h, just use this definition directly. A minus h is this one, and when you are using a plus h, so greatest integer of a plus h is equal to a. Then you can easily find, suppose we can check at x is equal to 2. One you have to do, this is for you. The left hand derivative, right hand derivative. So similarly, left hand derivative, as you know, this is at what point we are finding 2. You can write also L f dash 2 will be equal to limit h tending to 0 f 2 minus h minus f2 and limit upon minus h, because left hand derivative. Now you can see this definition. 2 minus h, 2 minus h will be equal to 2 minus 1. According to this definition, limit h tending to 0, 2 minus h will be equal to 2 minus 1, and f2 means greatest integer of 2 is 2 always. Because there is no negative sign, there is no decimal place, then 2 greatest integer less than equal to 2 will be 2. So 2 a minus 2 minus h is equal to 1 minus a, 2 minus. Yes. Yes, a minus 1. What is a? A is 2 minus h. So 2, okay, got it. 2 minus h, a minus h means fx. So x, whatever we are decreasing, okay, so we can have one minus 2 minus h. And definition of, okay, actually we have to write in terms of h, not directly here. So in order to cancel this h, so that's why f, if we are finding fx, any value fx, and giving some decrement minus h, so we can write 1 minus that, 1 minus that number. Okay, 1 minute. So this will become 1 minus h, and then minus f2, the value of 2 is 2. So a minus 1 minute, this would be a minus 2 minus h. So okay, greatest x means integer. So we have to find that 2 minus h means less than 2 minus h, 2 minus 1, 1. Yeah, it will be 1. We find the value of this directly, it will be 1, and this will be 2. So 1 minus 2 minus 1. But we have to use the definition in terms of h. So we are doing correct. H tending to 0, the value of 1 minus h is what? 1. As I told you, 1 minus 2 upon h. So this will be equal to minus 1 by h and limit h tending to 0. H tending to 0. 1 by h means 1 by 0. 1 minus 1 means 1 by 0. When you put h is equal to 0, this will become minus 1 by 0, that is infinity. And right hand derivative, similarly, if you find right hand derivative, so r f dash 2 will be equal to limit h tending to 0 f 2 plus h minus f2 on minus h. So 2 plus h is what? 2 plus h, as I told you, it is equal to a plus h means a. So 2 plus h will be equal to 2 only. So you can see that limit h tending to 0, 2 minus 2 upon h, not negative, positive h. So this is 0. This will become 0 upon infinity in determinant form, but we can write okay 1 by infinity into 0, so answer will be 0. So left hand derivative is not equal to right hand derivative at x is equal to 2. So fx is equal to this is not differentiable at x is equal to 2. Not differentiable at x. Okay. So